Welcome to this space that is reaching knowledge. At this moment, I've been pleased and honored to be with Mr. Roger Penrose, which is a quite well-known physicist and mathematician and emeritus from the Oxford University.
Thank you, Mr. Penrose. Nice to meet you. Thank you for this interview.
My pleasure.
Yes. Con gusto.
We've
listened to some of your lectures. You have explained some theories regarding the universe. What do you think that the scientific knowledge has evolved? Mathematics, geometry, physics, and in simple words, such according to your presentation, how does the universe started and what had happened in the development?
Well, I have a very geometrical way of looking at the world. I certainly have a mathematical way of looking at the world, but I like to express things also in pictures, which I draw myself, and I find that that is helpful for communicating ideas. Now, in my first talk here, the public talk, was one on a view of the origin of the universe. Well, you see, the usual picture is that the universe began with what we call the Big Bang. Now, the Big Bang, there's a lot of evidence did happen, and I'm accepting that evidence. However, I do not think that the universe started with the Big Bang. The current view of the way the universe exists is that there was a Big Bang first. There was a very early stage of what people call inflationary expansion, where the universe expanded enormously, and then it settled down to a more sedate expansion. Now, and then it started to expand again in an exponential way, so that we have just started to see this new kind of expansion. Now, that picture is fine for me, except for the very early stage of expansion, what's called inflation, because for various reasons, for a long time, I have not believed in that. However, if you don't believe it, you have to have a different explanation for certain things we see in the universe. Now, for various reasons, mainly to do with what is called the second law of thermodynamics. That's telling us that things get more and more random as time progresses. Now, this is a physical principle that we see happens. That means that if you go back to the Big Bang, it must have been very organized, in a way which has not been explained by any other theory. The universe has to be what is called a very low entropy universe. Now, the current views don't explain that. They thought inflation would perhaps explain it, but it doesn't. Now, I have a view then, which it's hard to explain, useful to have pictures to explain, but in an interview I will just say that my view is that the Big Bang was the beginning of what I call an eon, spelled A-E-O-N. And this eon started with the Big Bang, yes, no inflation, and it now expands, and is now entering this exponential phase of expansion. In my view, that is not the whole universe, because the universe will repeat. It will have a phase, an eon like that, and then another eon like that, and then another eon like that, and then another eon, and so on. In particular, there was an eon before ours. Now you might say, how could it be that this expanding universe, getting colder and colder and thinner, suddenly became a very, very hot, condensed universe, which seems nonsensical. But in this view, the universe sort of, it's hard to explain, but the universe sort of forgot how big it was. And it can do that when there is no mass around. See, when you have mass, like this chair or things like that, then you have a good notion of time and space. But in the very remote future, it's just light, like these lights here, and photons, that's light, which will be the main ingredient of the universe. They don't know whether the universe is big or small. So in the very late stages, the universe, which is big and stretched out and cold, is completely equivalent to a Big Bang. Now that's a strange idea, and many of my colleagues find it very puzzling, and so they think I am now maybe going crazy because I'm too old.
Pero tú dijiste que loco no es ser malo, que hay
You said that being crazy is not being bad. There's a difference of being a bad person and being crazy.
That's true. I think, you see, in a certain sense, there are many things that are crazy in the world. Quantum mechanics is crazy. But it turns out to be a good theory. This is a crazy theory. But I argue that actually explains many things. And this idea of the universe losing track of whether it's big or small is a crazy idea. But you could make sense mathematically of this idea. More important is that you can send signals. Now you see, I argue that signals are coming to us from the previous eon. Now I would ask, how could a signal come from the previous eon? How could a signal be so violent, so big, so enormous that it could get through? So I think, what is the most enormous event that I can think of? Well, you see, our galaxy is going to collide with another galaxy, the Andromeda galaxy. This will happen in a few thousand million years. So there's no danger. But when they collide, there will be, in the center of our galaxy is a black hole. A black hole which is about 4 million times the mass of our sun. 4 million stars in one black hole. And this in the center of our galaxy. The Andromeda galaxy has one which is, I don't know, 20 times bigger, maybe 40 times bigger. When we collide, okay, not immediately, but they will probably spiral around and swallow each other up. And when that happens, there will be one huge release of energy. Now that's not for us, this is in the future. But in the eon before ours, this will have happened many times. Occasionally galaxies collide, occasionally their black holes collide. And the signals from these, I claim, can be seen in the what's called the cosmic microwave background. This is radiation coming from our Big Bang. And people analyze this in different ways. But only recently have colleagues of mine started to look for these signals. And my claim is that you do see them. Many people are very skeptical, of course, because they think my idea is too crazy. But I think the evidence is there. Some other people have seen the signals, but they don't quite know what to make of them. So we need to wait to see.
Trying to follow the same order of ideas in your presentation of the expansion of universe, it could take us that this unknown idea or very incomprehensible idea of infinite. For our brain, we can understand your drawings in this box that you use in the slides. But in the universe, you don't have that box. So what are the boundaries or restrictions for the universe?
Well, you see, one thing about mathematics is you can learn things and understand how to understand infinity. See, infinity is something which is a little frightening if you are not familiar with mathematics. But when you learn about these things, you can realize infinity is not so frightening. And you can have ways of understanding. And so I draw pictures where the infinite universe is pushed into a small picture. And it's a realistic picture, but you have to know that the scale of time gets very, very squashed, you see. So it's as though your clocks, the seconds get squashed into years, you see, and the year gets squashed and the centuries get squashed, and you have everything coming up to one boundary, and that's infinity. And it makes geometrical sense. It certainly makes geometrical sense. Whether it makes physical sense is the question.
In a representation, that's true. So you cannot imagine those boundaries of the infinite. That's impossible then.
Well, you see, I say it's not impossible. Not impossible. No, you can. I give examples, you see, where the Dutch artist, yes, M.C. Escher, who has nice pictures, and I like to use one of these, where there are angels and devils, and angels and devils and angels and devils, and they look as though they get crowded on the edge, you see. Now the world that these angels and devils inhabit is infinite. There would be an infinite number of angels and devils right up to what looks like the edge. But that edge, you can see it. You can represent it as a nice mathematical picture that Mr. Escher had a very good way of drawing. But that is infinity for the angels and devils. So we use the same trick here, you see. We make infinity, squash it down, and you can look at it and make sense of it. Yeah.
That means in the box.
In the box. Yes, that's right. Yes. Yeah, yeah.
Okay. In this case, talking about the infinite, without a mathematical definition, but just hypothetically, we could have a spacecraft that is faster than the light speed. Where do you think we can reach?
Well, spacecraft will get very... Unfortunately, from this perspective, it is very limited. Maybe we will send a colony to the moons of Saturn. Maybe we will send a colony to the distant stars. But we have a trouble because the nearest star is something like 4 light years away. So, but that's not so far, you see. You could imagine signal can get 8 years to get out and back again. Well, you can wait 8 years. But that's very tiny in the galaxy. If you wanted to travel across the galaxy, this would take millions, centuries, I don't know how long. And so space travel is interesting, and I'm sure we will get information about a lot of things we don't know now. maybe we will colonize the galaxy, but it will be slow. And we won't make much impact on the hugeness of the universe that we see. Nevertheless, we could get signals, and maybe we could get signals from other civilizations, perhaps. Maybe even from the previous eon. Just conceivable.
Before the Big Bang, some scientists said that there wasn't anything and no time, but you said that is not true. So you mentioned something at the beginning. Before the Big Bang, what was it? And if there is some time, and also you mentioned to another universe in expansion. Was there something else?
Well, my view, I should explain also, this is a change of mind, which I had about 10 years ago. Before that, I would have said the Big Bang is the beginning. And you ask what is before the Big Bang, I would give the conventional answer, which is that there was no space, no time, and the question means nothing.
And after 10 years, what will be your answer?
After 10 years, I now say I was wrong. And that you can talk about something before the Big Bang. And not only can you talk about it, but that signals appear to be coming from that previous phase of the universe. I'm not quite sure I remember the original question. She was...
There was another measurable universe. Do you think it could take us to another measurable universe?
Yes. Well, you see, my view is that it's not really a different universe. There are many theories nowadays where people say, okay, one universe, our universe, there is another one, another one, another one. I'm not taking that view. I'm taking that all these are one universe, but they're different eons within one universe. And you can get signals from one eon to the next eon. So, although one eon is like a whole history of one universe, this is a limited view. And that what we experience in the universe that we have around us is something which has its origins in one before. And that had its origins in one before that. And so on indefinitely.
A human being could live an average of 70 or 80 years. This is too little compared with this universe history of millennials. We know that there are some bugs or insects that could last only for a couple of hours. So, what is the meaning of our lives in this planet? So what is your conclusion? Are we the bugs of the universe?
You address questions that I can't really answer here. We don't know. I mean, I don't know. It's, I mean, it's quite possible that I should not say too much because I don't. The main thing is we don't know. There could be, for example, experiences which continue even in another eon. You see, you could imagine a civilization could maybe have some way of preserving itself by sending signals which can be reinterpreted in a later eon. But this is all guess, you see. Maybe even an experience could continue elsewhere in a later part of the universe. I have no idea. So don't ask me to speculate too much on such matters. Okay.
What about religious discussions about the creation of the world? If mathematics and physics are giving more precise answers or more close to the creation of the universe, what happens with this creator God? Do you think it will disappear?
Well, I should confess that I am not a religious person. In the ordinary sense of religion, certainly not. I mean, there are many religions in the world now, and these religions have different, they have different stories which the religions relate to, and they have some things in common and some things different. I'm not someone who would believe in any one of these, you see. But each one may have a value in giving purpose to existence, and maybe these reflect something which is common to all of them. But I don't have any views about what I should think here. I mean, I think we know very little. You see, it has to do with what it is in the physical world which gives rise to a conscious being. And is that consciousness something which is restricted to something like a human body or a human brain? Or is it something which could extend beyond that in some way? And these are questions which I believe we are very far from being able to answer at the moment.
Time is a conception, and there are plenty of definitions according to whom you ask them, without having a mathematical answer. When you measure all these series of events, do you think we can manipulate the future, or what is time for you?
Well, time is of course, I'm a strong supporter of Einstein's view of general relativity, in which time is a personal thing in a sense. That is to say, especially if you have space travelers, as we were talking before, they can travel long distances and experience a different lapse of time from those who stayed behind on the planet. If they go out, come back again, they will age by less than those on the Earth. However, if you do take the time as a measure which is, I mean, and not just for a person, but a particle. You see, take an individual particle, and it will move around, and that particle will have its time. And that time may not quite agree with another particle's time, but very close to that. It would only disagree if the speed gets close to the speed of light. But nevertheless, given all that, there is a measure of time which is extremely precise. And there are clocks now which are incredibly accurate. And they're so accurate that if you could have had a clock right the way from the Big Bang to now, that clock could have been accurate to less than a second. And this depends on the fact that, well, it's really the two most famous and important little formulae of the 20th century physics. One of those formulae has to be Einstein's E equals mc squared. The other formula is Max Planck's E equals h nu. Nu is a Greek letter for frequency. So the first, Einstein tells us energy and mass are equivalent. Planck tells us energy and frequency are equivalent. So you put the two together, and this says mass and frequency are equivalent. So that tells you that a particle a stable particle which has a definite mass is a clock, which has a fixed frequency. And that frequency is very fundamental. So we have in the world very, very fundamental clocks. And these clocks are of the accuracy that I just described. If you can make a clock which actually uses this precision in nature. So time is a very, very precisely defined notion, but it depends on the particle. So if you have two particles and they move around and come back, the time will not be quite the same. But yet for each particle, the time is very, very precise. And the theory of relativity makes use of this. And also your GPS. You know the machine that you have in your car, perhaps, if you have one, which tells you where you are, is using time signals from satellites. And these signals are so precise that you can use the delays of time from different satellites to tell you where you are exactly. And this tells you that time of this kind that you see in relativity theory is an extremely precise notion. But then there's the question of how does that relate to our passage of time? How does time seem to pass? The conscious being experiences time passing and so on. That's very mysterious. And we do not know. We have very good physical time, which we understand very well in physics. We have the conceptual passage of time, which we all know almost nothing.
Do you believe that the mass that is captured by a black hole is being destroyed, or it is going to travel to another dimension?
It's a good question. No, it's an interesting question because Stephen Hawking, when he first discussed the radiation from a black hole, which is a very tiny effect, but when you talk about huge lengths of time, even a very big black hole will eventually lose all its mass in Hawking radiation, and it gets smaller and smaller and finally disappears with a pop. Big pop. However, he thought originally that information is lost, and that was a clear conclusion he came to. I think he was right. However, in later years, other physicists have got very worried by this, and Hawking, I think, has got too influenced by them, and he changed his mind. And he wrote an article saying, no, information somehow must get back again. I think that was a mistake. And for my conformal cosmology scheme, it's very important for the consistency of the scheme that information is lost in black holes. Now, why the physicists don't usually like this is because there is an important feature of quantum mechanics which goes under the name of unitarity. I think you just have to translate unitarity, which contradicts that. According to unitarity, you cannot lose information. And so they get worried, and they say, no, no, you cannot lose information. And that gets into all sorts of problems. But you see, my resolution of this is that I don't believe quantum mechanics to that level. I think that quantum mechanics, when gravity is involved, will not satisfy unitarity. And even when you ever make a measurement in quantum mechanics, unitarity is not satisfied. So it's okay for information to be lost in black holes.
Hoy en día, ¿para qué le sirve al ciudadano de a pie
What is the objective for a normal or regular citizen to know the origin of the universe? What is the purpose of knowing where you're coming from if we're just travelers of the world?
That's a good question. Of course, many religions have addressed this question in one way or another. And there are religions in which somehow there are repeats. I mean, Hinduism is a bit like that. But I don't know. I think the importance is just knowledge as a whole, and we don't necessarily know why we need that information. I think there is something of a feeling in human beings that they want to know where they came from, even if it's just one's ancestors. And then you want to know where they came from. And then you want to know where humanity came from, where life came from, where planets came from. And so it is a natural question, a natural continuation of that question. And I think it is natural for people to worry and to think about such things. And the importance does not necessarily have to affect our lives, but maybe it will one day.
It has been said that we are in the golden age of knowledge, where we have more scientists around the world than in any other time. However, we still are unknown on how our brain works. Do you think the human being could emulate brain intelligence, but you have said that computers won't be the same as a human brain, and we are not very familiar with the whole human brain?
Yeah. Well, you see, I mean, it's a question which I have tried to address. But the issue to me is the one of consciousness. You can have computers and they do very complicated things, more complicated than we could do. And they play chess very well, and so on. But they don't do it the same way as human beings do. They don't understand what they are doing. Now, to me, what understanding is something which is not a computer activity. There's something different. And it is something which requires awareness. You have to be conscious. In fact, this is very much the way we use language. I mean, we say, if a device of some kind understands something, it must be aware of something. How could it understand without actually being aware? But awareness is a feature of consciousness. So I say it could not be conscious without, it could not be understanding, it could not be intelligent without being conscious. Of course, it can be clever, if you like. It can do many complicated things. It can play chess well, but that doesn't mean it understands it. It doesn't feel anything. It doesn't have that quality. Now, you see, people may argue, well, what do you mean by this? What do you mean by that? And so on. And my arguments basically come from quite subtle things in mathematical logic. This is not, I'm not trying to say that mathematics is different in any way. I'm just saying it reveals certain things which we don't perhaps see the difficulty with otherwise. And the main thing is to do with this wonderful theorem of Kurt Gödel. Kurt Gödel showed that if you have any system of rules which you could put on a computer that can prove certain things about numbers, then if you look at the rules and if you believe those rules always only tell you true things, that they don't make mistakes, then you can construct a mathematical statement which will defeat it, but which you know is still true. Now, how do you know that? You know that because you know that the rules only give you truths. And that knowledge of why the rules only give you truths, or that understanding, I should say, of why the rules only give you truths, is not part of that system. And this is clear. So you can see that the concept of understanding is not following a given set of rules. And in a sense, this is always the way we use computers anyway. When I say always, it is the normal way we use computers. We supply the understanding. We know what the computer is doing. We know what the computer's answer means. The computer doesn't know what it means. It just goes brrrr. You see? It needs the understanding, and we have to supply the understanding.
In that part of the conscious and the human brain that we are not familiar with, you are compared with what we are still lacking of knowing in the universe. How do you make those analogies?
Well, you see, I think, of course, all these arguments are very contentious, and maybe other people will, we have many arguments. But my own view is that we need to look into the physics of the world to find something which is different from the way in which machines normally operate. In other words, which could be computed on a computer. And it seems to me that there is one big gap in our understanding. There are lots of other gaps, but there's one gap which is probably the one that's relevant. And this is within quantum mechanics. The quantum mechanics has two procedures, and they contradict each other. One of them is the Schrödinger equation, the evolution of a system, which you could put on a computer. It evolves the state. So you know what the state is now, you can work out what the state is in the future. But it doesn't tell you necessarily what happens. And Schrödinger himself was very clear about this. He said, okay, we could have a cat in a box, and my equation, that's Schrödinger talking, Schrödinger's equation would say that the cat could be dead and alive at the same time. That's what his equation says. And he says, look, this is absurd. That's not what happens. The cat becomes one or the other. And this is what's called the measurement process in quantum mechanics. And that process is in contradiction with his equation. And he realized that. But many people sort of forget that fact. And they try to say the world must operate by this Schrödinger equation, or unitary evolution. The same unitary we had before. Whereas I say, okay, the world works according to that up to a point, and then it does something else. Now what is that point? We need a theory to tell you what that point is. And I have certain ideas about when that point is, depending on how much mass is moved. And that such could be relevant to the way that the brain operates. So there could be a certain level at which this gap, which is inherent in quantum mechanics, is actually coming in, and that this is where some element of consciousness comes in. So this is a theory which my colleague Stuart Hameroff and I have developed these ideas, and we take the view that there are structures in the brain which are these are the microtubules which are also in other cells, but they have a special role in the brain, is the argument. And this argument says that a conscious perception has to do with these microtubules reaching a level where the quantum evolution does something different. And this is what we call an element of proto-consciousness. Maybe the sort of brick out of which consciousness is built is this element of proto-consciousness. Now this is a theory, of course. Maybe the truth is something quite different, but the idea we have is that conscious experience is built from these tiny events where quantum mechanics, if you like, these choices are made one after the other, and these choices combine together into one's feelings of consciousness, conscious free will, conscious actions.
Nice to meet you.
Good to meet you too. Thank you.
Y gracias a todos ustedes por estar aquí con nosotros en Alcanzando el Conocimiento, una herramienta vital. Hemos estado con Mr. Sir Roger Penrose. Gracias.